recording is started. Okay, so in the last lecture, our focus was on this expression. What do we mean by limit x approaches a of some function is equal to L exists means whenever x is close to some number a, y, which represent the values of the function, are close to L. And during this process, we are not interested in what is the value of the function. We don't bother about this. Function may not be defined and the limit can still be existing. X is close to a को represent करने के लिए हम x minus a mod less than delta, where delta is small, finite small number. And to keep x not equal to a, we put this 0. And fx close to L के लिए, we use fx minus L is less than epsilon, another small number. So we are in this process never interested in this thing. Okay, what is fa, which is the value of the function. Then we considered the concept of continuity, and we talked about the continuity over the entire domain, over an interval, and at a point. So our concern in as far as continuity is concerned was k limit x approaches a, fx is equal to L exists, and by that we mean unique, real, and finite. And this is also equal to the function value. Value of f at a. And that means once you know the concept of limit, how to find the limit, you find a limit. If it exists, then you check the value of the function. If the limit and the value are same, then you say the function is continuous. If the function is continuous, then we talk about the derivatives of the function. The heading is derivability of function, and whether the function can be differentiated or not, can we obtain the derivative of the function or not? That is the basic question which is addressed in this definition. This one, a function f is said to be derivable or differentiable at x is equal to a if the following limit exists. Now, how this limit is constructed? Here we must be clear that it is something else whose limit is being sought. If this limit exists, we say that this is the derivative of the function at x is equal to a, or we write down dy by dx at x is equal to a. So when you are asked to determine whether a given function f is derivable at x is equal to a, what you have to do? First step, you consider fx minus fa. The second step, you talk about x minus a. The third step is that you make the ratio of the two. And the last step, you take the limit x approaches a of this ratio. So this process is entirely different from the limit of the function itself. Limit of the function is something else, and derivability में जो limit इस्तेमाल हो रही है, that is a different thing. So at times, when we talk about limits, we say that x is close to a. The fact makes x is equal to a plus delta or a minus delta. But convention is that when we talk about derivatives, मैंने लास्ट टाइम आपको बताया था कि स्मॉल नंबर्स के लिए नोटेशन हम डेल्टा एप्सिलॉन और एच इस्तेमाल करते हैं. तो इस लिमिट को इवैल्यूएट करने के लिए वी ट्रांसफॉर्म दिस एज instead of x plus minus a delta, we use x plus minus a plus minus h. So x is replaced by a plus minus h. So wherever there is x involved, x is equal to say a plus h. इसका मतलब ये है कि as x approaches a, h approaches 0. So that this will change to another limit. X approaches a के बजाय h approaches 0. Wherever there is x, you write down a plus h or a minus h minus fa divided by x की जगह a plus h या a minus h, so that a cancels. So when we talk about derivability, we talk about replacing x by a plus h or a minus h wherever x is there in this ratio of x minus a upon x minus a. तो अगर मैं a plus h इस्तेमाल करूं तो डिनोमिनेटर विल बी प्लस h. अगर मैं x is equal to a minus h इस्तेमाल करूंगा तो डिनोमिनेटर विल बी minus h. A plus h means we are working on the right hand side, and we call this limit now right hand derivative. If we are using a minus h, so delta, epsilon, or h themselves are all positive real numbers. So to express right side, we consider a plus h. To express left side, we consider a minus h, and we get these limits.
नहीं 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 नहीं
Now
नहीं नहीं
these,
क्या है इस बैग में सब.
now when these limits exist and they are equal, then we say that the function is derivable or differentiable. If this limit exists, and existence of this limit means left hand side से निकालो limit या right hand side से निकालो limit, that means left hand derivative or right hand derivative दोनों बराबर हो, then we say the function is derivable or differentiable at x is equal to a. To demonstrate the idea using an example, हमने टाइप्स ऑफ फंक्शन डिस्कस करते हुए अलजेब्रिक फंक्शन का जिक्र किया था, ट्रांसेंडेंटल फंक्शन का जिक्र किया था. But of course you know that there are other kind of functions, piecewise defined function, functions that are defined using absolute value function. I hope you remember what's the meaning of absolute value function. Whenever the input is positive, the output is also positive. But whenever the input is negative, output is again positive. That means one branch is y is equal to x, one branch is y is equal to minus x. So that the graph is something like this. So I have considered in this example a piecewise defined function where to the right of 2 and equal to 2, function values, yani y values, have to be calculated using this formula. When x is less than 2, y value has to be calculated using this formula. Are you familiar with these kind of piecewise defined functions?
Yes, sir.
Good. Now, the graph of this function, I have shown it here. To the right of x is equal to 2, you see that the function To the right of x is equal to 2x minus 3. To the left of x is equal to minus 3. So I don't know if this graph is appropriate or not. Let me consider this function separately. Fx is equal to 2x plus minus 3. For each x, what? Greater than or equal to 2 and minus 3x plus 7 for each x less than 2. So you have one line 2x plus minus 3 and one line minus 3x plus 7. This is when x is greater than or equal to 2. And this is when x is less than 2. So when I make the graph at x is equal to 2, the value has to be evaluated from this formula. 4 x is equal to 2, this becomes 4. 4 minus 3 is equal to 1. This is the point. And if x was equal to 2, I would have used this. But I have just used this. लेकिन अगर मैं ये इस्तेमाल करूं तो इससे भी यही वैल्यू निकलती है. But this line y is equal to 2x plus minus 3 is like this with slope positive 2. This line slope negative 3 like this. So that graph is not appropriate. This graph is not appropriate. So we can follow this graph, and working is how if you go for finding the value of the function, it is 1. The graph is joined. So continuous left limit or right limit is same. Left limit or right limit are also 1. So the function is continuous at is equal to 2. However, we note that अगर मैं ये evaluate करूं x is equal to 2 पे मैं left hand derivative evaluate करूं तो f of 2 minus h लिखूंगा. लेफ्ट हैंड साइड के लिए मैं ये फॉर्मूला इस्तेमाल करूंगा. So minus 3x plus 7, this formula, minus 3x plus 7, x replaced by 2 minus h. Value of the function f of 2 is 1. Denominator is minus h. Simplify this and we get this limit. Numerator when simplified will be minus 6 plus 3h plus 7 minus 1. So 7 or minus 7 cancel, 3h upon minus h. So minus 3 will be the limit, h cancel out. Similarly, right hand side pe x is replaced by 2 plus h. In what formula? The right hand side formula. 2x minus 3. So 2x minus 3, you simplify this and you'll get this. So from left hand side and the right hand side, the derivative, the limits that we call left hand derivative and right hand derivative, they are not equal. So this function is not derivable. Now this graph is not appropriate. This graph is appropriate. What's the problem? Right side slope is 2. Left side, the slope is minus 3. What happens when you keep track of the slope along this line? This will remain 2 even when you are very close to 2. If you track the slope from the left hand side, this line will always have slope minus 3, however close you are to x equal to 2 on the left hand side. So the slopes from the two sides are not same. And there is a sudden change in the slope if you travel from left to right. There is a sudden jump in the slope. There is minus 3 value on the left hand side of x equal to 2 and plus 2 value on the right hand side. So in general, we say that continuity की geometrical representation जो है वो ये कि ग्राफ में गैप ना हो. डिसकंटिन्यूअस फंक्शन वो होता है जिसमें ग्राफ में गैप होता है, जो हमने लास्ट टाइम डिस्कस किया था, एक होल हो या जंप हो। डेरिवेटिव कब नहीं मिलता? So when a function is not derivative, that is a question. The derivative function is not derivable if this left hand derivative, that means this limit, and right hand derivative, that is this limit, are not same. ये तो लिमिट का मामला हो गया। ज्योमेट्रिकली अगर मैं देखूंगा तो इसमें मुझे सडन चेंज इन द स्लोप नजर आएगा। We can say that whenever there is in any graph, if there is this kind of situation, that tangent suddenly change its value at some point, at that point the function will not be derived, even if the function is continuous. So continuity is not a surety for derivability. This example demonstrates the fact that even being continuous at a point, the function is not differentiable there. The function will be differentiable only when the left hand derivative ye do limits equal. That indicates a special property of graphs wherever the graphs are connected and smooth without sudden change of the tangent line. The tangent line here can be drawn like this, drawn like this, drawn like this. So slope of the tangent line is not changing abruptly, it is changing smoothly. So smoothness का लफ्ज इस्तेमाल किया जाता है। कंटिन्यूटी के लिए कनेक्टेडनेस, कंटिन्यूटी, ग्राफ कनेक्टेड। derivability, graph smooth. Now it is familiar geometrical property that if this derivative exists, it represents the slope or the gradient of the line tangent to the graph of the function x is equal to a. We have already started using this concept. Sometimes ये जो x को हमने पहले a plus minus h से रिप्लेस किया था, there is a different scheme where we consider derivative at arbitrary point. When you consider derivative at arbitrary point, that means somewhere here, then we use a different process कि या तो हम x plus delta x इस्तेमाल करें या x minus delta x इस्तेमाल करें. So this is x plus delta x, this is x minus delta x. लेकिन हम इसको x plus delta x ही लिख सकते हैं. That means x जो delta x है, variation in x जो है, that can be positive or that can be negative. तो दोनों का काम एक साथ ही होता है. So a जो कि पहले एक फिक्स पॉइंट था, अब आर्बिट्री पॉइंट हो गया. x जो कि a के करीब एक पॉइंट था, उसके करीब x plus delta x ले लिया गया. So when I talk about x minus a, पहले ये plus minus h था, अब ये delta x हो गया. So denominator is replaced by delta x, and this is your well-known first principle of finding derivatives. Form of the basis of the first principle, and that is used to obtain the derivatives of basic functions. And you can prove that functions of this type, x power n, everybody knows that it is n times x power n minus 1. That means if you are talking about x power 3, the derivative process will give you 3x square. If you're talking about x power minus 11, this will give you the derivative as minus 11 into x power minus 12. Power multiplied, power decreased. So this can be proved using the first principle that has been set here. every major student require to prove all the basic derivative formulas. Even they are also required to prove this u into v rule, derivative of product of two functions. I hope you people are familiar with these rules, जिसको आमतौर पे लिखा जाता है derivative of u into v, that is u dv plus v du. If you want to write down dy dx, then dx comes here, d u dx comes here. So u into v rule and u upon v rule. I hope you people are familiar, aren't you?
Yes, sir.
That's good. Uh, there are many derivative formulas that can be proved using the first principle. For example, this can be proved, this can be proved, this can be proved, this can be proved. But then to prove the derivative of tangent to be p secant square, you have to use u upon v rule. Cot के लिए u upon v, secant के लिए u upon v, cosecant के लिए u upon v, b power x के लिए we have a different use of first principle, but first principle uh, can be used to prove this, can be used to prove this. We are not going to these proofs, but uh, using these u into v kind of rule, अगर product of two functions का पहला derivative है, so we can also find the second derivative of the product, third derivative of the product, fourth derivative, or nth derivative, like 10th derivative, using such kind of formulas. Wherever we will require this, we will use this. Then there are differential properties that are very useful in understanding general ideas of concept, increasing and decreasing function. Let me redraw an arbitrary function graph. Sorry. ग्राफ का ये पॉइंट क्या कहलाता है?
Turning point.
जोर से बोलो बेटा.
Turning point.
मेरे पास आवाज नहीं आ रही अच्छी तरह से. कमेंट कर दो. Stationary point. Yes, this is stationary point because at this point, one of the condition for a stationary point is satisfied. What is this point called? Now, if someone is wondering why dy by dx is 0 here, because if I draw a tangent at this point, this is horizontal, and that means slope is 0. Minimum stationary point. Somebody said that this is minimum stationary point. That means this is also a point which is stationary. तो यहाँ पे तो मैक्सिमम मिनिमम कहा गया. यहाँ पे इस स्टेशनरी पॉइंट पे और इस स्टेशनरी पॉइंट में एक चीज कॉमन है कि टेंजेंट हॉरिजॉन्टल है. इसको आपने मिनिमम कह लिया. इसको क्या कहते हैं? मैक्सिमम. अच्छा. Now there is an insect traveling along the graph. Is it gaining height or going down? It's gaining height. So we say the function is increasing. Then the insect reaches the maximum and no more gain of height. It keeps on traveling along the curve. Now, is it gaining height or losing height? Now it's decreasing. It keeps on decreasing its height keeps on decreasing until it reaches this minimum. And then if it keeps on starting along the graph, what happens to the height again? It starts increasing. So we say that there are some clear trends. When the function is increasing, dy by dx is positive because the tangent drawn should have a positive slope. When it is decreasing, the tangent has a negative slope, so dy by dx is negative. When it again rises, dy by dx becomes positive. Now, maximum. कोई भी पॉइंट मैक्सिमम होगा x इज इक्वल टू सी. पहला तो यह कि वो स्टेशनरी हो, एक बात. दूसरी बात कि मैक्सिमम का मतलब आप क्या लेते हैं स्टेशनरी के बाद, डेरिवेटिव जीरो के बाद क्या लेते हैं? व्हाट अदर कंडीशन रिक्वायर इज रिक्वायर्ड फॉर द पॉइंट टू बी अ मैक्सिमम? डेरिवेटिव तो सी पे जीरो आ गया. आप मैक्सिमम और मिनिमम के लिए डिफरेंशिएट करने के लिए क्या करते थे? डिड यू डू लर्न एनीथिंग टू डिफरेंशिएट बिटवीन मिनिमम एंड मैक्सिमम पॉइंट? दोनों पॉइंट्स पे डेरिवेटिव जीरो है, मैक्सिमम पे भी मिनिमम पे भी. इसका मतलब है मैक्सिमम भी स्टेशनरी पॉइंट है, मिनिमम भी स्टेशनरी पॉइंट है. इसका मतलब है मैक्सिमम पे भी डेरिवेटिव जीरो है और मिनिमम पे भी डेरिवेटिव जीरो है. बट मैक्सिमम और मिनिमम का फैसला कैसे करते थे? नो रिस्पॉन्स. मैक्सिमम मिनिमम नहीं किया. However, anyone? Let me remind you that if d square y by dx square second derivative निकालते थे is negative, fc is max, and if the second derivative is positive, then function value is minimum. इसको relative maximum और relative minimum भी कहते थे. क्या ये नहीं करते थे? क्या ये काम आपने नहीं किया? किया है तो बोल क्यों नहीं रहे यार?
Yes, sir.
यही प्रॉब्लम होती है
Yes,
यार
sir.
ऑनलाइन क्लास में और फिजिकल क्लास में. फिजिकल क्लास में चेहरे से पता चल जाता है कि क्या किया क्या नहीं किया. Now look, one thing I want you to attend to this thing. Before a maximum, the function is increasing. Just after a minimum, the function is decreasing. So if I can somehow work out on the left hand side, the derivative is positive, and on the right hand side, derivative is negative. That is an indication of maximum. At this stationary point. Now, similarly, on the left hand side of stationary point, the derivative is negative, and derivative is positive on right hand side, then the stationary point is minimum. Have you seen some such things before?
Yes, sir.
That's good. So here similar things are being revised. हम कहते हैं कि फंक्शन इस इंक्रीजिंग होता है कि अगर लेफ्ट एक्स पर फंक्शन स्मॉल और राइट एक्स पर फंक्शन लार्ज. डिक्रीजिंग होता है अगर लेफ्ट एक्स पर फंक्शन लार्ज और राइट एक्स पर फंक्शन स्मॉल. यहाँ स्टेडीली के लिए दोनों जगह इक्वल है. स्ट्रिक्टली जैसे कि हमारे ग्राफ में था, it is our graph. In this graph, it is strictly increasing and strictly decreasing. These are the cases. It can be easily proven that if a function f is differentiable over an interval, पूरे interval पे, तो पूरे interval पे इन function की strictly increasing के लिए condition derivative positive की है. इस interval को हम interval of increase कहते हैं. इसका मतलब है यहाँ पे इंटरवल ऑफ इंक्रीज जो है, जहां से भी ग्राफ आ रहा है, अगर यहीं से आ रहा है तो ये इंटरवल ऑफ इंक्रीज हो गया, और यहाँ से यहाँ तक फंक्शन डिक्रीज कर रहा है तो ये इंटरवल ऑफ डिक्रीज हो गया. अगर ग्राफ यहाँ पर कहीं खत्म हो रहा है तो ये फिर इंक्रीजिंग हो गया, तो दिस इज द इंटरवल ऑफ इंक्रीज. So intervals of increase and decrease. Similarly, we can prove that when the function is differentiable and strictly decreasing, the derivative should be negative. The interval is then called the interval of decrease, and so on and so forth. Thus, in order to determine whether a function is decreasing over some interval, we take the derivative of the function and explore whether the derivative is negative or not for all x belonging to the interval. So there is an example again, and the relative maxima and relative, here it is increasing, here it is decreasing, here it is increasing again. And you can find the relative intervals of increase or decrease. Similar relative maxima and relative minimum मैं आपको पहले समझा चुका कि अगर कहीं आपके पास relative maximum है तो derivative 0 होगा, इसका मतलब स्टेशनरी पॉइंट है. Derivative positive होगा close to a on the left, और derivative negative होगा close to a on the right. Similarly, relative minima has the property that is opposite, except the derivative the 0 होगा or is increasing to the right and decreasing to the left. So what happens that at in the interval there is a point maximum where the derivative changes its nature from being increasing to decreasing. At a minimum, it changes its nature from increasing to decreasing. And these lead to other ideas. There are some critical or stationary points where we don't have second derivative available, or we have a situation that the function is increasing and keeps on increasing, passing through a stationary point where the tangent is horizontal. And we call such a point, we give it a special name. This kind of point is an inflection point. What's the property of inflection point? F prime C is 0. इसका मतलब है स्टेशनरी पॉइंट तो ये है. uh, increasing on either side, दोनों sides पे, or decreasing on either side. Let us look at the previous graph. We don't have such situation here. The function changes its nature from being increasing to decreasing, and we have stationary points. We have maximum, minimum. Do we have inflection points here? So we need to look more closely for what the stationary inflection point is. Concavity and inflection points. Concavity upward or concavity down. This is a part of the graph, say, that I was using in my rough pages. Suppose किस तरह का ग्राफ है ये? Okay, increasing graph है. ये increasing graph है ऐसा कि यहाँ से जाके it goes down again. So this kind of a region is represented here. यहाँ पर जब हम इसको देखते हैं, English you can read easily. Let me discuss the graph itself. Here is a special point and versus speciality of this. On the left of this, the graph is such that if you make the tangent will be below the graph. On the right side, if you make the tangent will be above the graph. At this point, tangent will cross the graph. To the left hand side, the shape of the graph is sort of concave up. इसका मतलब है ये वो रीजन है जहां पानी स्टोर किया जा सकता है. On the right hand side, where the tangent is above, concavity is downward. इसका मतलब पानी से गिर जाएगा. So, if I talk about this graph, from here to here, the function is decreasing, no doubt, but in between there will be a point where to the left the tangent is above, to the right the tangent is below. Before this point, tangent is below. After this point, the tangent is above. So here the concavity is down. Here the concave, let me use another color for concavity. Concavity down, concavity up, and then concavity remains up, and then concavity goes down. So wherever the concavity changes, we have an inflection point. So एक inflection point तो वो था जो हमने ये दिखाया कि function remains increasing on either side of a stationary point. तो ये stationary point inflection point हो जाएगा. मगर अब जिस inflection point की बात कर रहे हैं वो stationary point नहीं है. उसके left पे concavity upward और concavity downward. अब concavity upward और downward का कैसे पता चलता है? Second derivative. Positive, concave, up. Second derivative, negative, concave, down. ये सारी इंग्लिश यहाँ लिखी हुई है. आई होप मैं ये फाइल ज़ाहिर शेयर करूँगा. यू कैन go through reading this English concept I have described. So a parabola which is concave up, a parabola which is concave down, a curve पैराबोला में जो कॉनकेव अप है इसमें एक स्टेशनरी पॉइंट है मगर इन्फ्लेक्शन पॉइंट कोई नहीं है क्योंकि कॉन्केविटी चेंज नहीं हो रही कॉन्केविटी चेंज नहीं हो रही यहाँ कॉनकेव अप और कॉनकेव डाउन there is an inflection point which is not a stationary point but it is a critical point because derivative is infinity slope tangent जो है वो vertical है यहाँ पे concave down यहाँ concave up at this point you have an inflection point but the derivative is not defined so critical point is the derivative now critical point आप जब पढ़ेंगे इंग्लिश या आपको याद हो तो क्रिटिकल पॉइंट दो किस्म के होते हैं dy by dx is equal to 0 और dy by dx not defined in the sense कि वो infinite हो या कुछ और zero ना हो infinite हो 0 by 0 हो something like that now here you have got concavity down concavity up concavity down concavity up there is here concavity down here concavity up so there must be an inflection point here concavity up here concavity down this is an inflection point concavity down concavity up there has to be an inflection point in between the geometrical properties of inflection point are discussed asymptote I think I don't need these asymptotes right now uh, as well as these mean value theorems, Rolle's theorem, rather Cauchy mean value theorem. But ये जो mean value theorem, intermediate mean value theorem, से ज़्यादा जो important चीज़ है, that is Lagrange mean value theorem. This Lagrange mean value theorem is an important theorem. Let me briefly describe Lagrange mean value theorem. Fx is continuous over some interval AB. Fx is differentiable over interval AB. Then if I put it on the graph, suppose this is the interval AB. At A, the function will have some value, and this point will have coordinates F, A, F, E. At this point, the function will have some value. I can take a higher value or a lower value, but this point will have coordinates B, F, B. If I join temporarily these points with a straight line, what will be the slope of this straight line? Can anybody tell me the slope of this straight line? Every file, every word that I write down and put on the file will be uploaded on LMS resources. हाँ भाई मैं ये पूछ रहा था कि इस पॉइंट को मैंने एक टेम्पररी स्ट्रेट लाइन से मिला दिया. Can anybody help me writing down the slope of this line? X1 y1 x2, y2. What's the slope of the line joining these 2 points? If anybody is in, yes, fb minus fa divided by b minus a. Now we have a condition that the function is continuous. इसका मतलब है जरूरी नहीं है कि फंक्शन स्ट्रेट लाइन हो. अगर स्ट्रेट लाइन होगा फंक्शन तो हर पॉइंट पे ये स्लोप होगा. Suppose the function is like this, or the function is like this. I have not only considered continuity while making these 2 graphs, but the differentiability also, that these 2 graphs are smooth graphs. When this be the situation, can I find a point on the graph somewhere here or somewhere here where the tangent will have the same slope? Can I? Let me try to draw a tangent here in order to show you that this tangent line will be parallel to this line. Tangent here, this tangent line will be parallel to this line. So when the function is continuous and differentiable, a और b के दरमियान एक point ऐसा जरूर मिलेगा where the tangent line will be same as the slope of this line that joins the starting and the last point. And this can be written in different forms. fb is equal to b minus a को उधर ले गए, fa को भी उधर ले गए. इसको एक और तरीके से भी लिख सकते हैं. If b is equal to a plus h, इसका मतलब है b minus a is equal to a plus h minus a. So b is equal to a plus h. What c will be? c a से आगे है मगर a plus h से पीछे है. So I can write down th where t is between 0 and 1. अगर t को अलाउ कर दूं मैं 0 होने के तो a plus 0 will be a. अगर t को अलाउ कर दूं 1 के तो it will be a plus h, that means b. मैंने t को अलाउ नहीं किया 0 के, अलाउ नहीं किया 1 के, तो 0 और 1 के बीच में होगा तो a plus t h जो है वो a और b के दरमियान होगा. So की c can be represented as a plus t h. So now fb, that is a plus h, is equal to fa plus b minus a, which is h, f prime a plus th. This kind of expression may be helpful for us in our study of integral calculus. So basic form of Lagrange mean value theorem is this. Alternate form is this. And another alternate and useful form is this. So out of these, Lagrange mean value theorem is important, and I have discussed the uh, idea of this, and I hope you have studied L'Hopital rule for finding out limit for indeterminate forms of the type 0 by 0, infinity by infinity, 1 raised to power infinity, 0 raised to power 0. Somebody asked me 0 power 0 जो है ये indeterminate form क्यों है? तो हमने कहा कि यार चलो थोड़ी देर के लिए 0 पावर 0 को 0 पावर 2 minus 2 लिख देते हैं. It will become 0 power 2 इंटू 0 पावर -2, जो कि हो जाएगा 0 पावर 2 अपॉन 0 पावर 2. So 0 power 2 is 0, 0 power 2 is 0. So this is the fundamental indeterminate form. Similarly, someone can ask me 1 raised to power infinity कैसे इंडिटरमिनेट फॉर्म होगा. तो मैं ये डिस्क्राइब नहीं कर रहा, आप थोड़ा सोचिए. और फिर जो डायरेक्टली 0/0 या इन्फिनिटी फॉर्म होते हैं उस पर आप डी एल रूल लगाते हैं. ये फंक्शन एफ एक्स डिवाइडेड बाई जी एक्स की लिमिट, वेयर एफ एक्स की लिमिट 0 है, जी एक्स की लिमिट 0 है, सो 0/0 फॉर्म है. इंस्टेड ऑफ दैट यू गो फॉर द limit of the ratio of the derivative of the function, that is known as L'Hopital rule. I want to terminate discussion a bit early because I have to attend one of my teacher, my research crew, who's not feeling well, and I am repeatedly being called by his wife that he want to meet me as soon as possible. So I've told him that I'll be reaching as soon as possible. But one last thing, टेलर एक्सपेंशन और मैक्लॉरिन एक्सपेंशन की मैंने ट्रांसेंडेंटल फंक्शन के वक्त बात की थी. दिस इज जनरल एक्सप्रेशन फॉर टेलर थ्योरम. When x is close to a, we have this Taylor expansion, and you can write down Taylor series infinite. तो ट्रांसेंडेंटल फंक्शन की जो सीरीज एक्सप्रेशंस होते हैं वो हम या तो इस टेलर एक्सपेंशन से निकालते हैं. If x is close to 0, अच्छा यहाँ हमने ऊपर लिखा हुआ है कि if the function is differentiable up to order n at some point x equal to a, यानी फर्स्ट डेरिवेटिव सेकंड डेरिवेटिव सारे डेरिवेटिव एग्जिस्ट करते हैं, तो ये टेलर एक्सपेंशन होता है. क्यों होता है? मेजर के स्टूडेंट्स को ये भी प्रूव कराया जाता है. ना इफ x is close to 0, इसका मतलब a की वैल्यू 0 है. So this will become fx is equal to f0 plus x minus 0, that is x, f prime at 0, x minus a whole square, that is x minus 0 whole square, that x square, upon 2 factorial f second derivative at 0 plus x minus 0 whole cube divided by 3 factorial f third derivative at 0, and so on. And the general term is x power n upon n factorial and another derivative at 0 plus so on. Have you seen such expansions? Have you used this Taylor expansion formula or Maclaurin's expansion formula?
Sir, is this the same as Taylor rule?
जोर से बोलना. Same as?
टेलर रूल जो बोलते थे हम, वो और ये सेम ही है.
Taylor rule. I don't know what you exactly
हमने लिमिट्स में पढ़ा था.
limits पे पढ़ा था Taylor rule. Aqib Imran is trying to say something. I don't remember any Taylor rule in the study of limits. But Taylor formula You haven't studied this before, and this is one culmination point of the study of differential calculus. Because my question, y e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x4 by 4 factorial blah 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 xn by n factorial indefinite. ये एक्सपेंशन कहाँ से आता है? वो यहाँ से आता है. I will discuss few things about this, जिसके बारे में मुझे कम से कम एक कमेंट नहीं मिला है कि तुम लोगों ने ये नहीं देखा. And somebody is asked me कि टेलर रूल यही होता है, तो और वो आपने लिमिट में पढ़ा था, तो ऐसा नहीं है. मेरे जहन में नहीं आ रहा बिल्कुल कि टेलर रूल लिमिट में कहाँ आता है. लाइबनिज रूल आता है डेरिवेटिव्स के अंदर. नो आई डोंट रिमेम्बर. आप भी जरा देख के आइएगा कि टेलर रूल एग्जैक्टली क्या था. अगर आपके पास नोट्स मौजूद हैं तो उसमें जहाँ टेलर रूल का इस्तेमाल ये लिखा हुआ नजर आए, आप उसकी पिक जो है वो मुझे पर्सनल व्हाट्सएप कर दीजिएगा. And then I will comment on what you actually mean and how it is related or not related to Taylor series or Taylor formula that I have written here. Now, with this comment, I have to terminate today's discussion and I'll be leaving early today. And sorry, one last thing before I terminate discussion today is that we have lost 250 minutes. No, 2 hours 30 minutes. Two sessions of 1 hour 15 minutes have been lost. I was planning कि मैं Friday this and next 7:15 to 8:30 p.m. मैं इस फ्राइडे को और अगले फ्राइडे को इन टाइमिंग्स में आपकी क्लास लेके आपका लास्ट टाइम जो है उसको कवर अप करूं. I will record these lectures. Those who can attend, they are most welcome. And those who are not able to attend, आप मेरी रिकॉर्डिंग जो है उसको ज़रूर देखिएगा और उसमें कमेंट में अपना ERP नंबर ज़रूर लिख दीजिएगा. वैसे भी जब आप मेरी रिकॉर्डिंग देखें तो कमेंट में ERP नंबर लिख दिया कीजिए. With that, thank you very much.